From here on Earth through the naked eye, stars look pretty much the same. But up close and personal, things get weird. One might say, super freaky. Black holes and supernovae are one thing, but a star that completely disappears when it dies? And has a kind of star seriously gone extinct? I guess there's only one way to find out, to watch Super Freaky Science. Of all the ways a star can conclude its explosive journey, one of the most dramatic is to be engulfed by a black hole. A black hole is an object in space that exhibits such strong forces of gravity that not even light can escape its pull. And from time to time, an unsuspecting victim gets caught up in its gravitational fury. While a star getting sucked into a black hole is typically a rare event to happen, astronomers have witnessed the spectacle a handful of times. The process starts once a star passes closely enough to a black hole, causing the star to shed its layers of gas until it is unraveled into a thin accretion disk surrounding the black hole. Here in our home solar system, we're located in an outer branch of the Milky Way. It's a less dense area as far as star population goes, but actually very quiet compared to the densely populated centers of galaxies. In these galactic hubs, stellar traffic is much heavier, which means a higher chance of collision. When stars collide, it's a space-time shifting event of maximum proportions. These events can be so dramatic that gravitational waves are sent echoing throughout the universe. Although the likelihood of stellar collisions is greatly increased within star clusters, like those in galactic centers, binary star systems are also a huge breeding ground for stars merging and crashing into each other. The fate of the colliding stars depends on the types of stars involved. Some merge to become bigger, brighter stars, while some trigger a supernova to take place. Speaking of high traffic areas of the galaxy, globular clusters are collections of stars that are bound to each other by gravity. They usually form a spherical shape and rotate around a central point. These clusters are like their own star system, and some majorly fantastic events can occur when these clusters come near another huge mass, such as a galactic center. The gravity of the cluster intertwines with the gravity of the passing mass and causes gravitational tidal shocks to the stars within the system. This causes a disruption in the sphere of stars, sending stars flying off in a tail. The other, more detrimental result from these events is an increase in kinetic energy within the system, in turn accelerating core collapse in the stars. When talking about the death of a star, the headline usually has something to do with the grand explosion of a star known as a supernova. A supernova occurs when a star is big enough to be above a certain mass and runs out of fuel to burn. This is a big deal because the constant nuclear reactions happening on a star are what keep it in balance with its crushing gravitational force. Once that counterforce to the gravity goes away, the star collapses in on itself with incredible force. And since every action has an equal and opposite reaction, the collapse that begins as an inward force turns into an outward force in the form of a spectacularly dramatic supernova. But not all supernovae are the same. They can vary in size and substance, and we'll see just how extravagant they can be, so stay tuned. The universe is an incredibly diverse creature, and every day astronomers are witnessing new, never-before-seen events and situations that show us just how truly exotic the far-off reaches of our galaxy can be. That is perfectly exemplified by the hypervelocity stars astronomers have recently discovered in the last decade. Due to a chance encounter with the massive black hole at the center of the galaxy, these stars have been catapulted by the galactic center's gravity. They're flying through space at incredible speeds up to 2 million miles per hour. which is enough to break them out of the galaxy's gravitational pull altogether. These stars are doomed to become lonely intergalactic rogues and exist for the rest of their lives in the emptiness of intergalactic space. See ya, space cowboy. Wait, a dead star that comes back to life and then dies again? If this information wasn't coming from brilliant astrophysicists, it would definitely sound made up. But somehow, it's not. Astronomers first witnessed this back from the dead situation in 2013 when two white dwarf stars collided and created a single new star. White dwarf stars are star remnants. They're a super high density leftover core of a star that's burnt out. So they're considered to be dead since they're no longer burning energy, aka no more explosions. So once these white dwarfs collided, it created so much energy and heat that the two formerly dead stars became one star and started nuclear fusion again, and thus back from the dead. And that's how this star currently is, but scientists think this second wind won't last long. They expect this little charade to last no more than a few thousand years, which is basically a last gasp when we're talking about the lifetime of a star. With all this talk about stars meeting their timely or untimely demise, one starts to wonder, what about our star, the Sun? What's the fate of our energy source here on Earth? For anybody out there worried about the Sun dying out anytime soon, take comfort because scientists think our beloved home star is only about halfway through its 10 billion year life cycle, so she's still got a good 5 billion or so years to go. That's a relief, but the question still remains. What's actually going to happen in 5 billion years when the Sun runs out of fuel? Well, our Sun is what astronomers consider an intermediate mass star. Once these stars run out of their original fuel, hydrogen, they start to burn helium instead. At this point, they balloon up many times larger than they originally were, becoming a red giant. At this point, unfortunately, Earth will be vaporized. Sorry about that. But once the red giant runs out of helium, the end is near for the star. It collapses down many sizes, shedding its outer layers, while its core hardens and cools and becomes our old friend, the white dwarf. The shedding of the layers leaves behind a gorgeous planetary nebula. Feast your eyes on these babies. Speaking of white dwarfs, these hard little star remnants are the cause of our next stellar death, a Type 1a supernova. Unlike a regular supernova, a Type 1a supernova is caused by a white dwarf that has acquired new material from a companion star. This event usually only occurs in a binary star system, where one star has become a white dwarf and the other is in its red giant phase. In this situation, as the younger, larger star enters its red giant phase, it grows into its white dwarf neighbor's space. And what happens then? Well, the white dwarf, being as dense and massive as it is, starts sucking up material from its bigger neighbor. This is a problem for the white dwarf, since white dwarfs are only stable up to a certain mass. And if that critical mass point is breached, it's doomsday for the white dwarf. Once the white dwarf has acquired enough mass, it's done for, and a Type 1a supernova takes place. These supernovae are distinguished by their lack of hydrogen present when astronomers observe the resulting light from the explosion. Okay, so typically a supernova will leave behind one or two stellar objects, either a neutron star or a black hole. But our next stellar death is a supernova so complete, everything is completely obliterated and nothing is left behind. How can this be? Glad you asked. As stars get more and more massive, their cores get hotter and hotter. In fact, if a star is big enough, say more than 140 times our sun's mass, there's so much energy in the core that things start to break down. In these cores, the energy is so high that the atomic nuclei within the core actually start to break down on a subatomic level. This reaction causes the pressure in the core to drop, which leads to a runaway effect and core collapse, and then, you guessed it dude, supernova. But not just any supernova. This type of supernova, known as pair instability, leaves nothing left. It's total annihilation. Did a star seriously go extinct, or are we just making this nonsense up? Well, per usual, we'll defer to what the scientists are saying. Apparently, astronomers are hypothesizing that early in our universe's life, there were insanely enormous stars that were at least 1,000 times the mass of our sun. These quasi-stars, as they're called, would have had a black hole at their core, and would only be able to exist before the universe had developed heavier elements like metals. They would have given off as much light as a small galaxy, but these stellar titans were short-lived. Scientists think they only lived for 7 million years, which is very short in normal star terms, and super long in YouTube video terms, so that's why we're wrapping this baby up. Thanks for watching Super Freaky Science, and don't forget to subscribe.